Today we've got a super quick demo. I've got some steel framing in here in Revit. None of this was drawn by hand, it was all done by a script with Rhino Inside. And here's how to do it. And a reminder that you can get more tutorials like this at our website, and you can also download the scripts if you prefer rather than building them yourself from the videos. And feel free to have a look at some of the other services we offer, including model conversion, reinforcement, visualisations, etc. So once you've got Rhino Inside installed on your computer, you can open up Revit and you'll find that you've got a tab called Rhinoceros. So this is still a work in progress, so it's probably going to be cleaned up a little bit. Right, so if you click the Rhino button, you'll see that Rhino pops up, and I've got Grasshopper here as well. But the difference being that this Rhino actually runs inside this Revit session. So to see how this works, I'm just going to put some points down. I'm going to put another point at 5,000. Then I'm just going to draw a line between the two. Then I'm going to copy this object. I'm going to copy it 8,000 on the x-axis. And then I'm going to do the same thing again, but this time 5,000. And then the same thing again, but this time 10,000. Then I'm just going to draw some lines across the top. So we're just basically making a pretty simple frame with a few different spans. Okay, so now if we go into Grasshopper, I'm just going to put a curve, and then I'm going to inherit. I'm just going to inherit the top. So hold down Shift and just get the beams, which are the top of the frame. Set those, and you can see it's popped up in Revit. You can see that line which represents the curves that are in Rhino. So you can see Revit's already understanding what's happening. Now I'm just going to do another curve for my columns. I'm going to select that one, that one, that one, and that one. So now I've got my columns, my beams in the green, and my columns. Okay, so under Grasshopper, you'll have a new tab as well called Revit. To create some beams in Revit from your lines, you just need this component, which is Add Beam by Curve. Pretty simple. This needs a curve, a type, and a level. The level's pretty easy. If you go to Document, and then you've got Document.levels, if you put that in, that just grabs whatever's in Revit at the time. So I've obviously got 2 levels already set up, but that's pretty easy to do. Now we only need one of those levels, so I'm just going to use the good old Grasshopper select item, and I'm just going to use level, the base level. I could easily set that to 1 if I needed to. The type is something that is you've got to get your head around for Revit, and it uses the components that Revit uses in terms of families and types and all that sort of stuff. So the first thing you need to do is load a family. If you go to the Revit tab, you'll have family and family load. So you need path and a few filters. So path's easy, that's just a normal Grasshopper file path. Add an existing file. Now you're going to have to find this path in your computer system. It defaults to program C drive program data, and then it might be slightly different for your computer, but that's where it is in mine. I think that's default. And I'm just using the, once you get to libraries, you'll find whatever country you've got or region. I've just gone through to structural framing, steel and Australian standard. And I'm going to select UBs, universal beams. Put that in there. So now it's extracted, Grasshopper's extracted a family. So that family has all the universal beams for Australia in it. So the next step is we have to select one of those beams because we only want one type, one size of beam in other words. And if we go to family, and there's family.getTypes, this will take a family, which we know we've already got, and it'll give out all the types in that family. And the types are effectively all the UBs, all the standard I sections for Australia there. So if we think back to our add beam by curve, we need one type. So we've got all the types there. So again, I'm just going to use the select I'm just going to select one item out of that list. It's set to index as 0, so it's already selected one, but I'm going to set up a slider so I can select whatever beam I want. Make it a real number, it has to be an integer, and I think there's about 15 beams or so. So now if I just display the output of this, I can see that I'm selecting a 610 UB125 at the moment, but I can just flick through all the beam types. So there's more than 15, but anyway, I'll stick with a 410 UB59.7. I can put that into type, and then I have got my curves, which are my beams highlighted there in both the Rhino window and in Revit. Plug that in, and there you go. You've got your beam in Revit. So just to prove what we've done there, if I zoom in Revit, you can see I've got 3 separate beams and they're native Revit families to Revit. So you can change any properties you need to. I can change the justification or anything else through the properties separate to what Rhino's telling it, which is pretty sweet. So you can see how powerful this program is because you don't have to draft every single beam. You can just get the script or Rhino to bring steelwork straight in from a bunch of lines. Pretty awesome. Now if we go back into Rhino and Grasshopper, the reason I put the columns in there is I just want to show you that Revit treats columns differently to beams in terms right down to the very fundamentals. So what I mean by that is if you tried to put this family into your vertical lines, Revit will get very confused. So I can prove that by using the same information. And here I'm building a column, by the way, add column by curve. If I use those same curves, or no, sorry, if I use the column curves, have a look what happens. So it's got really confused. And the reason is beams, although they can have a slant, it's not seeing them as columns. As I said before, Revit thinks of things in beams and columns are actually got a whole different set of properties than beams. So you have to do things a bit different. So if I disconnect those, and I'm just going to go into Revit and delete these elements. Now another thing you'll see here is that they're locked by default. So I can't delete them until I unpin the elements. Then I can hit delete. Okay, so the secret of this is I can't use this family or the types either. So I'll disconnect that. But I can use the same system. So I'll just copy these components. And I've got to choose a column family rather than a beam family. So if I go up to mine's Australia, it's not structural framing, it's structural columns. I'm going to get UC, which is universal column in Australia. Right, so now we've got an output of, well, let's copy this as well. That's giving me a 200 UC52, which is fine. So I'll put that in there, and now we can use the column vertical lines. And there you go. So if I go into a Revit, just to highlight this, see this, it sees it as a universal column, and the columns have different properties, like the base level and all that sort of stuff. Whereas beams are universal beams, and they have start levels and off end levels and all that sort of stuff. Okay, so now I'm going to put some secondary framing in, and I can show you how Revit updates things when it's coming from Rhino, which is a little bit funny to get your hand around. So I've got my lines in Rhino, which are the beams and the columns, and I'm just going to move some of these. I'm going to get a vector. I'm just going to set the Y vector to 6,000. I'm going to have two of these, one for beams and one for columns. Okay, so now I want to split up these curves, the beam curves. So that we've got some intermediate framing coming across. Now to do that, I'm going to get the length of the curves of the beams. So I've got our spans 8, 5 and 10 meters. Go to maths and I'll divide. I want to split up these spans into a number, which I'll put into a panel, which will be our maximum span of our decking if this was a composite structure. So I've got primaries along here, I'll have secondaries running this way, and the decking over the secondaries only has a maximum span of 2,800 or 2.8 meters, which is usually pretty safe for composite decking. So if I divide the lengths by that number, I'm going to get some results which I need to round up. So if I do round, it's called ceiling, and I put that into the number of divisions. So just to prove that, I've got my first span is 8 meters. If you divide that by 2.8, you get 2.857. If I round that up, that's 3. So in other words, I'm breaking up an 8 meter span into 3, which you'll find is less than 2.8, so that's correct. Alright, so if I put my original beam curves in there, you can see how it's split up. So say our decking was a lot worse and it could only span 1.8 meters. You can see it's split up the primary by a lot more. Okay, so now that we've got that, I can use this same split up on the original beams as well. So we've got those two, and then we can just join them together. So that's our secondary beams. Now to bring them into Revit, I'm going to use this component again. I'm just going to copy and paste that. I'm going to copy and paste this as well, put that into type, but I'm going to use a different slider for it. It's going to be something a lot smaller. Now, you might have noticed that this is turned red. The reason is it's getting a bit confused because it's trying to overwrite two elements on the same location. So I really need to be using these lines, which I'm going to flatten just to keep it simple. Okay, so it's still getting quite confused because you've got to realize that Rhino is a bit independent from Revit. So the best thing to do in some cases like this is to get rid of these elements. And then you hit this button, which is Recompute. And it's figured it out. Now there is something that I forgot there, which was it's writing two beams in the same plane. So what I need to do there is cull duplicates when I get to the points. I just want to get rid of the duplicates, and then well, let's just flatten them all there and do the same on the other side. And join these lines up. Okay, so again, I'm going to have to delete these manually at the moment. Then go to Recompute. And it's done the secondaries correctly, however it hasn't done because it's trying to redo all the other framing. So you can see that the way it's set up at the moment isn't ideal. Still a work in progress. However, it is very promising on what you can do. So if I delete those, recompute, you've got everything you want there. So that does give you an idea of the state of the abilities at the moment. And it's just partly the way Revit works, in that when it writes something, it has to be able to, you have to be able to undo the previous step and all that sort of stuff, which doesn't work exactly the same way as Rhino works natively. So just to finish this off, I'm just going to add the new beams to the beam component and the new columns to the column component. And if I just disconnect that and reconnect it, you've got the whole frame there. So I hope that was useful to show how quick and powerful Rhino.inside is to get framing, structural framing into Revit really easily, but at the same time showing that it does have a sort of a funny workflow that can be a bit frustrating. Again, this is a work in progress, so they may have worked out a way to make this workflow really smooth in the future, and it's just not quite there yet. But anyway, I'll probably do some more videos later, but leave a like and subscribe if you enjoyed, and I'll see you in the next one.